So looking at question 16, page 13, question 16. It says that a car salesperson is paid according to two different relations based on sales for the week. In both relations, S represents sales and P represents the amount paid. So P depends on S. So for sales of less than 100,000, I get P equals 0.002 S plus 400. So for sales less than 1,000, and for sales for 1,000 and over, it follows this relationship. State the domain and range for each relation. Okay, so the domain for each relation is, well, sales. The domain is for the dependent variable, S. So what can it be? Well, sales S is an element, we can say, of real numbers, really. And even though it's only to cents, but that's fine. We'll say S is an element of real numbers such that S is greater than or equal to 0. That's a domain. And the range, we'll just write the range here. The range is for P. Pay is an element, actually, the truth is, for the first relation, there's going to be a domain and range. Let me redo that. Because this one is only valid from 0 to 100,000. And this one is only valid for 100,000 and more. So let's try and do that. Done. Let's move that. So for, let's just erase some of that, so clean it up. And we'll call P equals 0.002 S plus 400. So base pay is 400. So that's the domain of this. The domain is S, element of real numbers, such that S is greater or equal to 0 and is less than, actually let's start from 0. Let's just write a 0 here and 100,000 here. So is greater or equal to 0, but S is greater or equal to 0. 0 is less than S, and S is less than, not equal to 100,000. And of course, the range of this function is P is element of real numbers such that P is just greater or equal to 0. And that's the range of this function. Now we have this function here. P equals the second one. P equals 0.0025 S plus 400. The domain is S is an element of real numbers such that S is greater than or equal to 100,000. That's the domain of this function. And the range of this function, I wonder whether to be specific. It's an element of real numbers such that p is greater or equal to, and really we have to see where it starts. And it starts at s equals 100,000. So let's substitute. So for this, we need to find out where it starts. And because it starts at 100,000, p equals 0.0025. S is at 100,000, right? For S, we want to find out where it is for 100,000 plus 400. And what this means is we have 1, 2, 3, 4, 5 zeros. So we're going to move this 1, 2, 3, 4, and 5. So P equals 250 plus 400. And the answer to that is P equals $650. So as long as P is greater than 650, that's our range. Okay, so that's our first thing. Does each relation define a function? I think so. Yes. Why? Well, if we were to draw it out, and let's do that. I'm just going to go ahead and draw it out. And I have, that's 100,000. Okay, so when I draw my first one, it starts at 400, and it increases, the slope is really small. And here the slope is a little bit bigger. So I'm going to draw this, the first one. Whoops, why do I keep writing 10,000? The first one would look something like that, right? This would be, let's just pretend that's the case, okay? That is, we'll call that number 1. We'll call that number 2. We'll call this equation 1. The second one, whoops. The second value, we'll just make it blue. It's a little bit higher. We'll call that number 2. Now, the way this works is, at 100,000, 1 is defined. 1 is defined. Right? And 1 is not. So at 100,000, let's do a pixel eraser. That's defined. But also at 100,000, this one's not defined at all because of the range. No. And at 100,000 exactly, this is defined. Now, if I draw a vertical line test anywhere, there's only one value. Even at 100,000, there's a specific value. 100,000 of sales, there's a specific value of pay. Okay? And that is actually 650 for here. Okay, so let's read it. Graph two relations on the same set of axes. Okay, so I graphed my relation on the same set of axes. I already did that. And connect what happens on the graph at s equals 100,000 to its meaning to the salesperson. Okay, so what happens here? What does this mean to the salesperson? Well, it means the following. At 100,000, you get a little bit of a bump in pay. Okay? So the difference between 99,000 and 100,000 is not just linear. It's actually a significant bump. And to find out exactly how much that bump is you put it in the equation. So in equation 1, P equals 0.002 times 100,000 plus 400. Oh, and you know what? I made a mistake with this. It's actually, what's interesting about this is that actually this should be a little bit, whoops, Actually, the mistake is the following. I'll just draw it really quick. Let's go object eraser. Should pay more attention to the details. Let's draw it out again. And I have my axis. This is at 400. They both start off here. Okay, and then one of them goes up like that. And then at 100,000, let's call that 100,000 right there. Whoops, undo, switch it to pixel. At 100,000, that's undefined. 100,000, that's undefined. And it looks something like this. This jump is how much? That's what we're trying to find out. P equals, move this 1, 2, 3, 4, 5, right? So this equals 200. Let's not cross that out. Let's follow proper mathematical form. So the answer is 200 plus 400, which is equal to 600. So at here, if this was defined, it would be 600. And because this is defined here at 650, the difference between the first relation and the second relation is $50. And that's just a bump of $50. The moment you hit 100,000, you get a bump in pay of $50. And just a more accelerated rate for your future sales. And that's how you do question 16.